This is problem number 3 for assessment number 9. At what points is the following function continuous? They give you a rational function. They tell you it's not defined at x equal 10 and x equal negative 10. And we know that's true because we're dividing by x squared minus 100. If you plug in 10, you get 0. If you plug in negative 10, you also get 0 for the denominator. So the function itself is not defined at those 2 points. So they define it in this piecewise function saying x equal negative 10 will be negative 15 and x equal 10 is 8. Now, can this function be continuous throughout its domain? Well, I'm thinking it can't be continuous throughout its domain, but I'm not positive. What we need to do is we need to find the limit as x approaches negative 10 for the function to see if that gives us negative 15. If that's true, then it's continuous there. And then do the exact same thing with the limit as x equal 10, or limit as x approaches 10, and see if it equals 8. So let's start by doing the limit as x approaches negative 15 for x cubed plus 1,000 all over x squared minus 100. Now we're going to need to factor both the top and the bottom to find this limit, because if you plug in, well, technically not actually. We're going to plug in negative 15 right away. We can use direct substitution to do this. Oh, I don't want to go against negative 10. I screwed that up. Sorry. Let's just erase that out. We're going to find the limit. I want it to equal negative 15. I want to find the limit as x approaches negative 10, not negative 15, for x cubed plus 1,000 over x squared minus 100. So I cannot use direct substitution because if I plug negative 10 in, that gives me a 0. So I need to factor the top and the bottom. So I'm going to say limit as x approaches negative 10. Now how do you factor a cube plus another cube? Because 1,000 is a cube, right? 10 times 10 times 10. This is how you factor the cubes. You say a plus b, so in our case that'd be x plus b, which would be 10, right? So in this case, a is x and 10 is b. So we're going to say x plus 10 times, and then it says x squared minus, this will be x times 10, so minus 10x, plus b squared, which b squared is 10 times 10, which is 100. That's all over x squared. Well, we know x squared minus 100 is actually x plus 10, x minus 10, because we have a difference of squares there. We can see the x plus 10s cancel, and we're left with the limit as x approaches negative 10 for x squared minus 10x plus 100 over x minus 10. Let's plug in the negative 10 and we get 100 plus 100, right, because negative 10 times negative 10, plus 100 over negative 20. So that's 300 over negative 20, which is negative 15. So this limit equals the function defined at that spot. So that means it's continuous at x equal negative 10. So we can say continuous at x equal negative 10. Now we need to find the limit as x approaches 10 for this function. I'm just going to plug this in. We can do the same factorization. We'll just start with this. X squared minus 10x plus 100, because we'll have the same factorization, over x minus 10. And when we go ahead and take a look at this, again, we don't have, well, if I do direct substitution here, that's not going to work out for me very well. So I need to, let's see. If I plug in 10, let's do something close to 10. How about that? We'll go something close to 10 on each side. So if I pick 10.1 and plug 10.1 in. We get 10.1 squared minus 10 times 10.1 plus 100 all over 10.1 minus 10. So let's plug that in, and when we do that, and the reason I'm doing this is because we can't do it directly substitute because of the bottom. So 10.1 squared minus 10 times 10.1 plus 100 divided by 0.1. That's going to be 1,000. So we got 1,010.1. And if we made that 10.01 squared minus 10 times 10.01 plus 100 all over 10.01 minus 10. So 10.01 squared minus 10 times 10.01 plus 100 divided by 0.01. That's 10,000. So you can see that this is not going towards 8. So because this is not veering off towards 8, right? This limit is not towards 8. We can say that this thing is continuous from negative infinity to 10 union 10 to infinity, because it's continuous at x equal negative 10, but it's not continuous here.